Okay, now we're going to continue with our discussion of the origins of modern astronomy. So when we left off, we had Tycho Brahe observing the sky very carefully, using his eye. But he went back to the idea that the Earth was stationary. So with Tycho, he hires Johann Kepler to work with him in the lab. And when Tycho died, Kepler became the head of the observatory. What happened? Tycho then used all of this observational data to help further the model. And what he found is that one, the motion is not circular. And he also found that the motion is not uniform, meaning that it speeds up and slows down. Okay? So what he comes up with using Tycho's observational data is that the planets move around the sun, so heliocentric model, but they move in an elliptical path with non-uniform velocities. So the orbits of the planets are elliptical with the sun at one of the focuses. Okay, but the other one is empty. So ellipticals have two, and the sun just happens to be at one of them. So this is Kepler's first law that he comes up with. Kepler has 3 laws. The first one is that the planet's orbits are elliptical with the sun at one focus. His second law says that if I draw a line from the planet to the sun and allow the planet to move, it is going to sweep out an area. Okay, this area is given in the blue, going from A to B on the right side and A to B, A prime, B prime on the left side. Okay, so it's going to sweep out these areas. And when it does that, the areas will be equal to each other. Which means that there will be times when the planet will be going faster, which is the side closer to the sun, and there's times where it will be moving slower, which is the furthest away from the sun. Again, because he discovers that the motion is no longer uniform, but it speeds up and it slows down. Now his third law talks about the period or the time that it takes a planet to go around to make one complete revolution. He takes this time and then he squares it. And what he finds is that it is related to how far the planet is from the sun. Okay, and that distance cubed is what's going to be related to the period squared. Okay, so he has connected the period, which is going to be measured in years, period is the time that it takes it to go around, to the distance in astronomical units from the sun. Okay, so those are Kepler's 3 laws. Galileo, and most of us are familiar with that name, he actually moved science from this faith-based ideal to the modern scientific method that we have today. About the time he comes along, the telescope has been developed. Okay. So what he does is use the telescope to perform observations which support some of the things that Kepler has already discovered.
It's 8 o'clock.
So his observations are going to support Copernicus' model. Again, this is a heliocentric model of the universe with the sun in the center. And then Kepler has improved on this model by saying that the motion is now going to be elliptical. So one of his major discoveries is going to be, he discovers the 4 moons of Jupiter. And these moons are referred to as Galilean moons. He also is able to observe the ring of Saturn. He was also able to observe sunspots on the sun by using his telescope. And he proved that the sun is not perfect, because if you remember, back when we had the philosophy, it says that the universe is 2 parts, the perfect and the imperfect, and the perfect was everything in the heavens. Well, the sun was a major part of the heavens, but Galileo now proves that it is not perfect. He's also able to observe the phases of Venus. Okay, these phases of Venus are similar to the phases that we see on the moon. Okay? And by seeing these phases, he's now able to prove that Venus is orbiting the sun. Because if it was not orbiting the sun, if it was orbiting the Earth instead, you would not see these various phases of Jupiter. But since it is revolving around the sun, I'm able to see the phases of Jupiter. So this brings us now to Newton, Isaac Newton. We're in the late 1600s, early 1700s, and what he does now is to build on Kepler and Galileo's work. So now he brings the physics interpretation to the mathematical descriptions that we now have. Some of his major achievements, he had to invent a new form of mathematics to describe the motion. So he is credited with inventing calculus. He discovers the 3 laws of motion. And we looked at these 3 laws during the last unit, the unit dealing with physics. And he also discovers the universal law of gravitation. So this universal law of gravitation says that any 2 bodies that have mass are going to be attracted to each other through gravitation. Okay? So as long as 2 objects have mass, there is a gravitational force between those 2 objects. And I can calculate the force because I know the force is going to be proportionate to, or it's going to be equal to, it's going to be related to the product of the masses. So I multiply the masses together. So the large m and the small m represent the masses of the 2 objects. And this force is going to be inversely proportionate, or it's going to be inversely related to the square of distance. So the further I get away, the further I go from this object, from this large m, the weaker the mass gets. The weaker the force gets. Okay, and it drops off as a 1 over r squared. Okay? And G, in this capital G in this equation, is representing this universal constant of gravitation. Okay? It is this universal law of gravity that now allows him to explain why the planets are orbiting the sun, why the moon is orbiting the Earth. Okay, it's due to the force between the 2 objects that you can actually calculate with this relationship. Okay, so this was our lecture on the origin of modern astronomy.